All right, we're going to go ahead and continue with our set of review lessons. Hopefully, it's only going to take us a couple of days. By Wednesday, we can finish this up. This is just linear functions, and it is a review for a lot of folks. I'm hoping that this is going to help several people in the class, though. Just with the basic algebra. After this, we'll do a little more with quadratics and then move on to exponentials, and then we'll finally be able to start getting into some geometry and right triangle trigonometry. Excuse me. But this is the end of the 6 weeks, so I've got some information up here on the board. The focus activities does not apply to you because we haven't had any recently. So the only 2 grades remaining for you guys will be the homework that we just turned in, the relations and the functions. But also tomorrow, what I was referring to a few moments ago, the administration asked that we specifically take the class Tuesday the 12th to perform a writing sample. So I've got a couple of prompts that I'm going to have you guys choose from, and then you'll just have the period to go ahead and write me a one-page little response to it. Nothing big. It's just something that we have to go ahead and do. But I am going to record it as an exam grade, so that'll give a little bit more incentive. Hopefully, if your grade is a little lower, that can absolutely really help kind of boost that up a little bit. But we're going to have to do that tomorrow, and then we'll get back to this on Wednesday. Okay, so let's see what we're talking about here. We want a review of lines, starting with slope-intercept form. Okay, so that's y equals mx plus b, where the coefficient of x, the variable we call m, is my slope. Okay, that's always constant. It's always my rate of change, rise over run, a lot of different ways to go ahead and talk about it. And b is your y-intercept. That's where the graph touches the y-axis. Okay, well, let's just go ahead and get right into it. Example 1, write an equation in slope-intercept form, y equals mx plus b, for this line shown. Okay, now what I would probably go ahead and do is just start with the points that we have here. So this one is what? -1, 4. Well, this one is 2, 3. Now, there's different ways to do this because when it comes down to it, you've got multiple versions of how to write a line. We're going to talk about slope-intercept, y equals mx plus b. We're going to talk about point slope. We're going to talk about double intercept. Maybe you have heard of that one, maybe not. And then we've also got standard form. So a lot of different versions, and each one has its own unique characteristics, but they all represent the same line. They're just different versions of it. So here, some people, if they want to do it algebraically, you can go ahead and find the slope using the formula. Does anybody remember? I referred to it as rise over run a moment ago. You were probably taught the change in y over the change in x. Okay, but what am I going to do with these ordered pairs to figure out the slope? I mean, what is the formula? Okay, Spencer's absolutely correct. Y2 minus Y1 over X2 minus X1. And it does not matter which point you label as the 1s and which one is the 2s. If we say this is X1, Y1, then this would be X2, Y2. It's just the difference of the y's over the difference of the x's, and there we go. So let's go ahead and plug everything in. So y2 would be 3 minus 4 divided by, we got 2 minus a -1. Now we know ultimately this should come out to what? Positive or negative? How do we know negative? There you go. And yeah, you're talking algebraically. I'm talking visually just because the line drops to the right. Okay, so we should know it, it's going to be negative. But that does give me -1 over 3. Remember what happens when you subtract a negative? Yeah, you're just turns to addition. So the 2 plus 1 gave me the 3. Now, if you like, the formula, absolutely. If I have the line in front of me, what I like to do is just find it visually. I create a right triangle getting from one point to the other. Okay, the vertical is your rise. Okay, so we have the 1, and then the horizontal is the 3. And because we had to go down, of course, that would be negative. Okay, and if you had to go up and to the right, absolutely, that would be positive. Okay, so now we've got one part of it. We have the M, but now we don't have the B. And this is one thing I like to do. Remember in mathematics, we're not very creative when it comes to naming things. Like, why do you think we named an equation point-slope form? Because what do you need to write it? You need a point on the line and you need the slope. So personally, I would probably go ahead and just use one of these points with the slope we found, go ahead and write the equation. But you can also do it this way, because we're about to talk about point slope in just a minute. Y equals mx plus b. We'll choose a point. John, what do you like? The -1, 4 or the 2, 3? He likes the 2, 3. So I'm going to use this point. I've got an x and a y. We just found the slope m. I'm going to plug everything in. So y equals would be 3 equals the slope -1/3 times the x value of that same point, 2, and then plus b. You could just work backwards and figure out your y-intercept. Okay. Like I said, personally, I kind of like to use point slope because you just manipulate it and it's going to give you a slope intercept immediately. So let's see. What is a -1/3 times 2? Is a -2/3 plus b. Okay, so I'm going to add that 2/3 over. Okay, so those are going to cancel. So what am I looking at here? 3 2/3. So let's go ahead and make it an improper fraction. Okay, 11/3, right? Okay, so 3 2/3. Do you guys remember how to convert that? Start with the denominator, then you multiply, and do what with the numerator? Add it. Okay, good. So let's say 11/3. All right, now we just need to write out my equation. So y is equal to a -1/3 x. That was the slope we found, plus 11/3. So that should be that coordinate right there. That should be 0, 11/3. Okay. Like I said, this is going to be hopefully really easy for a lot of you. I just apologize if it's boring. Just kind of, bear with me. I want to make sure that everybody is on the same page. Okay, so if you have questions, please, let me know. All right. Let's take a look at another one. Write an equation in slope-intercept form for this line. Now, we have it visually. There's actually one thing on the previous problem we did I don't have to do here. What do I immediately have just by looking at the line? Yeah, you already have the y-intercept. In fact, that would be at 0, 3, right? So I know that the y-intercept is already 3. Would anybody like me to run through the formula, or can I just go ahead and say the slope looking at it visually? Does anybody want me to use the formula? No? Okay. So if I want to go from this point to this one, I'm going to create a right triangle. So I had to go down 2. How far to the right? 6. So I had to go down 2, 6 to the right. So it looks like, again, I got a slope of a -1/3. So I just put them both together, -1/3 x plus 3. And there we go. Okay. Questions? Easy? Okay. Well, all right. The point-slope form of the equation is the line y minus y1 equals m times x minus x1, where m is the slope, and x1, y1 is a point on the line. Now, you're going to be substituting in for y1, x1, and m, only those 3. This x and this y, they're what we call generic variables. They have to be there as part of the equation. Typically, the 2 variables you see most often are going to be x and y. Okay. Now, I've always taught it a particular way, and I'll go ahead and show you why I do that. But if we have this form here, y minus y1 is equal to m times x minus x1, okay, well, we've got the slope m. Here's the x1, here's the y1. Okay, so it's just a matter of plugging in. But when we substitute in, we always take the opposite of the points in the value, or the value of the point, okay? So because that's a -2, I'm going to say plus 2 equals, what's my slope? -3/5. And if this helps you know to write the formula right next to it so you can see exactly where you're plugging in, okay? Then since I have a +5, I'm going to go ahead and say x minus 5. Okay. I've always taught it when you write the point slope form, you just take the opposite of those values. And typically that makes things go a lot smoother. Really, it's not like you're taking the opposite. Does anybody know why that happens? Yeah, the formula is always y minus and x minus. So for example, if I were to go ahead and plug in a negative value, y minus -2, see that automatically changes to a positive. And if you plug in a positive, well, the negative isn't going to be affected. Okay. And here we go. Well, that's it. Just like that. Anybody having a hard time? Easy? Okay. Okay, well, let's see what else we got. What is an equation in slope-intercept form of a line that has a slope of 2/3 and that passes through the point -3, -1? Okay, so how about Caroline? Using that point and slope, what is my equation? Remember, we want this form. Y minus y1 is equal to m x minus x1. Okay, so y plus 1, again, we're taking the opposite, times what? And there you go. And here's the thing, the form that you're asked to give your final answer in, that may not always be the form that you initially write. Like, for example, if you do have the slope and the y-intercept, but you want point slope, I would probably just go ahead and write slope-intercept and then rewrite it to look like point slope. Okay. Or if you wanted standard form, definitely start with those and then manipulate the equation so that you have the form that you want. Bless you. Okay. Is everybody okay with how we did that? Does anybody want me to rewrite this into another form? The slope-intercept, for say. Did I make a mistake?
Is that supposed to say point slope instead of point intercept or slope intercept up there?
Oh, I wasn't even paying attention. I'm sorry. Yeah, it's supposed to be slope-intercept. Okay, well, I guess I can. Yeah, basically what I was talking about is still going to work because we didn't have the slope. So, well, we had the slope, but not the y-intercept. So, I'm sorry, my head is not in the game today. I apologize. So why don't we just go ahead and do what I was saying? Let's rewrite this. So what would I do if I wanted to put this in slope-intercept form? Distribute. Okay. So this would be y plus 1 equals. So that would be 2/3 x plus 2. Okay. And then all we got to do is subtract the 1 over so that y is equal to 2/3 x plus 1. So you see, I still have the same slope, but I now know that the y-intercept would be at 0, 1. Okay. There we go. Everybody's okay with that? Okay. Example 3. What's the equation of the line through 2, -3 and -3, 7? Now this one doesn't say specifically what form. It just says write an equation. So I'll leave that up to you. But either way, we need something. We need slope. It's the most important aspect of a line. So we're not able to do it visually here. So I would go ahead and use the formula. Let's just say we're going in this direction. Let's say this is x1, y1, x2, y2. So this would be 7 what? Plus 3, because we subtracted -3. And then down below, -3 minus 2. So that's going to give me 10 over -5. So my slope is -2. Okay. So let's see. Sierra, what form would you like? Would you like point slope or slope-intercept? You want point slope? Okay. So we've got the slope. What point would you like to use? The first or the second? Okay, first. Okay. All right, so John, using this point, 2, -3, and a slope of -2, what is the point slope form of that line? That's right. Oh, no, now, remember the form, that's y minus y1 equals m times x minus x1. So we're using this point, that's my x1, y1, and this is my slope m. So we just want to substitute in and get that equation. So what am I plugging in for y1?
Y1 is 5.
Ooh. Oh, that's right. -3. So if I were to plug a -3 in there, how does the equation change? We're subtracting a negative. That'd be y what? Oh. What happens when we subtract a negative? It turns the value, starts with a p. Positive. Okay. So it'd be y plus 3 is equal to, now what's my slope? Negative 2. So see, I'm just going to plug it right in, times, that'd be x minus, now what am I plugging in for x1? 2. Okay. But it's not like this one, we're not subtracting a negative, so minus the 2, nothing changes. Okay. So if we wanted it in point slope, that's all I need. Does anybody want to rewrite that in slope intercept? No? No? Okay. Well, good. Well, let's try that again. What's an equation of the line that passes through 2, 5 and negative 1, 3? Let's do this one in slope intercept. Okay, so I'd probably start with point slope and then just go ahead and convert it. So, got to find the slope first. Okay, someone go ahead and tell me what I should put in the numerator. The x's or the y's? The y's. It's always the y's over the x's. So I can write 5 minus 3 or 3 minus 5, as long as I go in the same order. Okay, what do you guys like? 3 minus 5? Okay. So we're going to go in this direction. So I don't have a choice with the x's. I have to say negative 1 minus 2, right? Negative 1 minus 2. So let's see. That's going to give me negative 2 over negative 3. So the slope is 2/3. Okay. And Evelyn, what point do you like? 2, 5 or negative 1, 3? 2, 5. Okay, so using this point and this slope, let's see, who have I not talked to today? How about Peyton? Okay, using that point and slope, what is the point slope form of that line? Okay, so y minus 5 equals. Okay, there you go. Now let's go ahead and rewrite that in slope-intercept form. So what did we do on that previous problem? The first thing was to distribute. So 2/3 times x, that's 2/3 x. And that's the thing, once you have the equation of the line, you can easily manipulate it into any other form you want. You just have to get that equation first. And now what's 2/3 times negative 2? Okay, that's going to be 4/3. Okay, all right. And what's my last step? I go ahead and add the 5. Plus the 5. Okay, so let's see, those are going to cancel. Y is equal to 2/3 x. So we're trying to get a negative 4/3 plus 5. So what am I looking at? 11/3. Okay. Now here's what's really cool. Does anybody want me to take the other point, write it in point slope, put that in slope intercept? Should be giving me the exact same form, the exact same line. Would anybody like to see that? No? Feel good? Okay. Does anybody have any questions so far? You guys remembering this? Easy? Good. Good. Okay, let's talk about some standard form. The standard form of the equation of a line is ax plus by is equal to c, where a, b, and c are real numbers, and a and b both cannot be 0 at the same time. One of them can, but not both. And there were 3 restrictions, and I believe a while back we actually brought these up. Does anybody remember one of them? Now, not every standardized test follows these, but if it's in true standard form, you have to follow these 3 rules. Okay, no decimals. So no decimals, no fractions. No decimals or fractions. Okay, that's one. What's the second one? It's something about a itself. A can't be negative, so a must be positive. A must be positive. And then the third one deals with all three values, A, B, and C. Common what? You're on the right track. It's not denominator, though. Starts with F. Common factor other than 1. Okay. So A, B, and C, C right there, can have no common factors except 1. Okay. All right. Now, it's that last one that always kind of trips people up. If I were to give you something like, let's say 6x plus 10y is equal to 12. Okay. Well, A is positive. There's no fractions, no decimals, but they're all divisible by what? They're all divisible by 2. The only common factor they can have is 1. So if I were to divide through by that, this would give me 3x plus 5y is equal to 6. Now, that's exactly what I was hoping somebody would say. Is this okay? This is actually okay. But why are some people saying no? What are they getting hung up on? There you go. The 3 and the 6, they have a common factor with what, right? With 3. But here's the thing. The rule says A, B, and C. So it's okay if 2 of them have a common factor other than 1, but not all 3 of them. So see, what divides 3, 5, and 6? Just 1. So that's perfectly fine. Is everybody okay with that? Okay. All right. Well, there are shortcuts here, and this one actually is typically what you're given. Say if you're trying to solve a system or you're just given the equation of a line, it's always this AX plus BY is equal to C form. And without manipulating it, without changing a thing, we can find out 3 important things about this line. We can figure out what the slope is. We can figure out the x-intercept and the y-intercept without lifting a finger. Okay. In fact, the slope is always going to be found by taking the opposite of A and dividing it by B. If I change the sign of A and divide by B, that will immediately give me the slope of this line. Okay? Don't have to change anything. Now, for the x and the y-intercepts, this is where the graph touches those axes, right? So if I'm looking for the x-intercept, whatever he is, what's the value of y? 0. And same thing when I have the y-intercept. Okay. Well, if I go ahead and take the constant and divide by the coefficients of x and y, that's going to immediately give me those intercepts that I'm looking for. If I'm looking for the x-intercept, it's going to be c divided by a. What do you think the y-intercept is going to be for that one? What ratio? C divided by b. Okay. And that really makes sense because let me choose one of those. Let's actually solve this for the x-intercept. Well, if you're looking for the x-intercept, y would be 0. But anything times 0 just disappears, right? So if a times x was equal to c, how would I solve that for x? I divide through by a, and see, there's the ratio. Same thing is going to happen if x is 0. Now, let's actually go ahead and put this in slope-intercept form. Ax plus by is equal to c. So I want to rewrite this so that it's y equals. Okay. What would I do first? Okay, get rid of any extra terms. Okay. So minus ax. So by is equal to negative ax plus c. See, they're not like terms, so the best I could do is just write them side by side. Okay. Now we're getting close. How would I get y by itself? Divide by b. Okay. Now we know this form is y equals mx plus b, where m is your slope. But see, that's what I just told you the slope was a moment ago. If you take the opposite of a and divide it by b. And we had that ratio c over b is your y-intercept. Okay. And see, it's really useful because if you wanted to graph it, you got those 2 intercepts, 2 points is all it's needed to make a line. Okay. So let's put it together. Let's see what happens. 4x minus 5y is equal to 7. Is this in simplified standard form? Yeah, there's no fractions, no decimals. Okay. A is positive, so 4 is a positive number. And nothing divides 4, 5, and 7 except for 1. So this is A, this is B, and this is C. Okay, so let me create a little table here. All right. Can anybody tell me just straight by looking at it, what is the x-intercept? Remember the ratio was what? There you go, C divided by A, so 7 divided by 4. So immediately, if we were to go ahead and kind of simplify that, that would be 1 point what? 1.25? Oh, a little higher. 1 point. 1.75. Yeah, because the remainder is, well, not 75%, but you have 3 remaining out of the 4 divisor. So I can immediately go ahead and say 1.75. That would be right about there. Okay. Now the ratio for the y-intercept was C divided by B. So what would that be? 7 over negative 5, so it'd be negative 7/5. Okay. And what's negative 7/5 as a decimal? Negative 1 point, or negative 1.2 and 0.4.
Negative 1.2.
It'd be 4. Okay. 1/5 would be 0.2. So negative 1.4, so maybe right about here. I think I went a little further down than I needed to. But see, now that you know the location of those 2 intercepts, and see, we didn't have to do a thing to the equation. I just knew those ratios. So I know my line has to look like this. Okay. In fact, let's go ahead and figure out the slope. The slope is the opposite of A divided by B. So we should be ending up with something positive, right? So what's the opposite of 4? Negative 4, bless you, over B is negative 5. So the rise and run should be 4/5 because the 2 negatives are going to cancel. Okay. And let's actually put it to the test. Just like I changed AX plus BY equals C a few moments ago, well, let's do the same thing here. Let's see if our answers are matching up. So 4x minus 5y is equal to 7. I want to rewrite this so that it's y equals. What's the first step? Minus 4x. Okay. Those opposites cancel. Remember, the negative drops with that 5y. They're not like terms, so the best I could do is just write them side by side. And then now what? Divide by negative 5. Okay. So we've got y equals, there's the 4/5 that we got for the slope, minus, because we have a positive divided by a negative, 7/5, and we know that's the y-intercept. Okay. There you go. And see, that's kind of the point. When you have standard form, you don't have to manipulate the equation. You don't have to go through all that if you can remember what those ratios are. Remember, C over A for the what? What intercept? That's the x-intercept. C over B for the y-intercept. And what's the ratio for the slope? Negative A over B. There you go. Okay. How many of you guys were taught that back in maybe Algebra 1 or Algebra 2? Actually shown those ratios. Okay. I think, Haley, didn't I teach you that? Back in Algebra 2? I think so. The last time I taught that. Okay. All right. Any questions? Anybody having a hard time? Kind of a stroll down memory lane? Remembering all this stuff? Okay. Okay. Now, if you change standard form in the following way. All right, so I'm going to do this here because I have more room. AX plus BY is equal to C. Okay. So I'm going to do a little bit of manipulation here. This form is what we refer to as double intercept form. It's not taught as often as the other ones. It's just as useful, though, especially if you're looking for a really fast way to get the equation that you can then change. How many people have ever heard of double intercept? Okay, well, I'm glad I can show you something new. Here's how you do it. You take your standard form, and I want to make sure it equals 1. So how can I guarantee that whatever that constant is, it equals 1? Divide by c. I'm going to divide everything through by c because it's an equation. Okay. All right. So this is going to be a over cx plus b over cy is equal to 1. Now, you remember we see this rule a lot in algebra. If you're dividing by a fraction, then that's the same as multiplying by its reciprocal. So this rule is reversible. If I'm multiplying by a fraction, that's the same as dividing by its reciprocal. So a over c times x, that's the same as saying x over c divided by a. Plus, same thing here, multiplying by b over c is the same as dividing by what? C over b. Okay. And it equals 1. This is what we call double intercept. Why are we calling it double intercept? Do you notice anything about those denominators? Yeah. C divided by a was your x-intercept. C divided by b was your y-intercept. There you go. So if you know the intercepts of your line, you can immediately plug those in, and you could rewrite it into standard form. You could rewrite it into y equals mx plus b, any form you wanted. Okay, it's just manipulating it. Okay, so let's take a look at this one right here. Now it's kind of hard to tell. I'm saying the graphic isn't the best, but let me go ahead and create a table to make this a little easier. This table represents the x and the y intercepts. Okay, so we can tell from the graph the x-intercept is what? Okay, looks like negative 1/3. Okay, and what's the y-intercept? 2/5. Okay, so if I know the intercepts of a line, well, then I can immediately just plug in. I can immediately say that x over its intercept plus y over its intercept should equal 1. And right there I have the equation of the line, and I can do whatever I want with it. Okay. Why don't we go ahead and put this in standard form? Okay. So while this is double intercept, okay, let's just kind of reverse that process on the proof I gave you to get here. If I'm dividing by negative 1/3, that's the same as what? Multiplying by negative 3. So this would be negative 3x plus what? I'm dividing by a 2/5. So that means I'm multiplying by 5/2. Y is equal to 1. Now we have the form for standard, but what? Yeah, there's a fraction, and there's something else I got to take care of. Remember, a can't be negative. We want it to be positive. So let's go ahead and take care of this all in one step. Some people like to take care of the fractions and then change the negative. I would multiply by what? Negative 2. That's going to take care of all the problems here. So that will give me 6x minus 5y equals negative 2. And that's what? That's standard form. Okay. So now let's take standard form. Let's rewrite it in slope-intercept. Okay. So that means I want to solve for what? So I want this equation to now read y equals. Okay. So this would be negative 5y equals what? Negative 6x minus the 2 that's already there. Now what? Okay, divide through by negative 5. Okay. So that would be y equals, what would be my slope? 6/5. Hello. So that would be 6/5 x plus 2/5. Okay. So that right there is slope-intercept. And let's confirm to see that everything's working out. Look back at standard form. The ratio for slope was the opposite of A, so negative 6 over B. And that gave me what? 6/5. Okay. What was the ratio for the y-intercept? C over A or C over B? C over B. So 2 divided by -5. Or excuse me, -2 divided by -5. What's the only form we don't have? Point slope form. Now, to go from here to point slope, what you're going to want to do is just factor that slope away from the x. Okay, I've got to pretend like he's a GCF. So y is equal to, I'm going to pull out the 6/5. Okay, but what am I going to multiply 6/5 by that would leave me 2/5? And here's the thing, this trick always works, but people have trouble, especially when they're dealing with fractions. Whatever it is you need, take that 2/5 and divide it by what you're pulling out, the 6/5. Okay, that works every time. It'll give me what I need here. So I'm dividing by 6/5, so what's that mean? That would be 2/5 times 5/6. Because 5s are going to cancel. What is 2/6? 1/3. And let's just double check it real fast. If I multiplied 6/5 times 1/3, 6 times 1 gives me 6. 5 times 3 will give me the 15. And what is 6/15 going to reduce to? Okay, that's going to be 2/5. Okay, which is exactly what we had there. Now, do you notice anything? What point was actually used to create the line we have in point slope? Remember, think about the form that it uses. We have y minus y1 is equal to m times x minus x1. Okay. Oh, 0, -1/3? -1/3, 0. Well, you remember way back when we first started this problem, what was the x-intercept that we were given? Okay. So all 4 of these, they are completely different equations. Double intercept, standard form, slope intercept, and point slope. But they all what? Every single one of them represent the same line. If I were to graph any of them individually, I'm going to get that line right there. Okay. Questions? How are we doing? Okay. All right. I don't think we have a whole lot more to go. I think we have one more example, and then all we got to do is talk about parallel and perpendicular, and we are done with this review lesson. We'll do that on Wednesday, because remember what's happening tomorrow. We got to do a writing assignment. I do apologize in advance for that. It's just something that we have to do, so I can get you a good grade. Hey, Peyton. If you want to take care of it later, otherwise I'll just exempt you. Okay. All right. All right.